Okay, looks like we're ready to go. Good morning, everyone. Thanks for hanging in there. This first part of the program, I'm Dave Peterson. I'm Professor of Forest Biology, University of Washington, School of Environmental and Forest Sciences, also an emeritus scientist with the Forest Service Pacific Northwest Research Station. And as I told you before, I'm also a tree farmer, so that takes up a big part of my life as well. And so the things I'm going to talk about today, because I'm also a scientist and tree farmer, they're very personal to me. I'm very passionate about the science part of it and how it affects my own land, how that affects the legacy of our forest for our daughter and future generations. So this is both a professional and personal interest of mine. What we will do here is cover some things specifically about climate change effects on forests with an emphasis on Washington. We'll definitely talk a bit about Western Washington as well. And we'll try to build on some of the physical principles that Jessica talked about. At the same time, I will try to allude to some of the other topics that will be talked about later today. So I will mention certain things, and then you'll get more specialized follow-up on those. Okay? So, has anybody seen this kind of stuff around? Yeah, a few of you. Yeah, these dead cedar tops, dead hemlocks, and so forth. It seems to be prevalent throughout Western Washington the last few years. I felt like this last year, maybe we got a little break from that. Anybody feel the same way? Yeah. Kind of peaks in 2018, I think. But it's certainly something that has caught the attention of forest landowners and the public. And people are trying to figure out, well, is this going to become a more common thing? You know, what's going to happen in the future? And I always like to start off with this map of USDA hardiness zones. Anybody a gardener out there? Grow plants? Everybody know which zone you're in? 7, 8, okay. Well, the thing is, those zones have changed. And the Department of Agriculture has actually acknowledged this with the development of their maps. Up in the top, we have the 1990 map. On the bottom, we have the map that was revised in 2012. And you'll see that the colors have shifted in that map, including in the Northwest. Look at the change in the colors there. So those zones have shifted around. And I'll have to say, there are some aspects of climate change that might be okay. You know, you get to grow some things maybe you couldn't grow. I've got a lemon tree sitting in my backyard. It's doing just fine right now. I've got a bay tree out there. No bananas yet, but I see those around Seattle once in a while. So anyway, I try to look at this with an open mind. I think there's a tendency on gloom and doom. And I try to be really kind of value neutral about the science and information and look at both positives and negatives of this topic. Just to focus on this here, which says average annual extreme minimum temperature. That's what this map is based on. Jessica mentioned that the minimum temperatures are getting warmer than the maximum temperatures. It's a faster rate. So that has some real meaning in terms of how, when, and where plants can survive in the future, not just for gardens, but also forest trees. So this is a pretty significant, small, important effect. Okay. I want to just state a few things up front to establish a context for everything else I'm going to talk about. We need to disabuse ourselves of the fact that we're dealing somehow with natural systems here, because 90% of all the primary forests have been harvested. All of our landscapes have been fragmented by all these various factors, reducing connectivity. A lot of our forests have a lot of non-natives, insects, pathogens, so forth. And as Jessica mentioned, these droughts have been uncommon since the 1930s. We've been living on borrowed time. And I have a feeling that a lot of this recent tree mortality we're seeing is just forests that are getting hit by a drought for the first time in their lifetime. And we're getting a bit of a thinning going on, especially in our denser stands. Good or bad, depending on how you look at it, but I think this is something to think about. And I just threw this in because we always forget about the lack of beavers in Pacific Northwest forest systems, especially at low elevation, compared to what it was in the 1800s. Our landscapes used to look completely different. They were fragmented by ponds and lakes and dead trees and this constant source of disturbance on the landscape. So just a good word for the beavers. And they seem to be making a comeback in some areas, which you may judge as being good or bad depending on how you look at that issue. All right. So one of the questions I get the most is, well, how are the species going to change? What will the distribution and abundance be in the future? And I would like to present 3 different sources of scientific information on this topic: paleoecological data, vegetation modeling, and then life history information. Don't try to perceive this whole thing and read it all. This is a pollen diagram. Pollen diagrams are created by sticking a core down into a lake or pond, pulling up this core of sediment, and then that core can be aged, going from the present back, in this case, 19,000 years. So once you analyze the pollen, you can determine which were the dominant species over time. So we can look at this case in pine, and we see that, and this is in Mineral Lake, which is over in Mount Rainier area, we can see that coming out of the last glaciation, pines were very common in the low elevation landscape. Bump this over, we look at picea, spruce. Spruce used to be extremely common in the cooler, wetter environment. Abies, firs, were not very common here, and then they suddenly became common about 9,000 or 10,000 years ago. Douglas fir is a relative newcomer on the landscape. It was not in that post-glacial environment initially, and now it's one of our more common species. Western hemlock, again, relative newcomer in the last few thousand years. Western red cedar, again, in our recent period. In alder's a survivor. It was common throughout most of this period of time. It's a disturbance-keyed species, so as long as you have some fires going on, some kind of disturbance, it can come back. Why do I show you all this stuff? This shows you how some species are relatively more or less common depending on the climate at the time. And we don't want to put a lot of quantitative focus on this, but I just want you to realize things have always been changing over time based on climatic variability, sometimes in response to relatively small temperature changes. So this is a context. Another way we can look at this is from vegetation modeling. In this case, we have some different species here. We have the area covered here in hectares, and then we have going from the present off to 2100, end of the century, and we are extrapolating this to show the relative commonness of species in a warmer climate. We can see that our subalpine parkland tends to go down. Our subalpine species like mountain hemlock either stay the same or drop down a little bit. Western hemlock may lose a little bit of that. Douglas fir is a winner. Okay, so there are not all losers in the climate change lottery. Grand fir is projected to do quite well in the future too. So these are just general expected trends based on what we know about these species. Another thing that has been done in the past, and this is a list that was developed for Gifford-Pinchot National Forest, is to rank species based on their life history characteristics. You know, how they're distributed, reproductive capacity, their habitat specificity, genetic variation, susceptibility to insects and diseases. And if you choose to do it, you can round this all up and develop a score. The species at the top of this list are considered to be more vulnerable to a warmer climate. The species at the bottom are considered to be less vulnerable. These are relative rankings. We don't put a lot of importance on these numbers. But this is at least somebody's estimate of what we might expect about our species that are winners and species that are losers in Washington in the future. Now, if you're a real keener, you may have noticed there are some conflicts between this table and some of the previous evidence I showed you. And that's science for you. It's not all consistent. That's why I always say, you know, with the climate change conspiracy amongst the global scientific community that you hear about, scientists are not that organized. They would never be able to agree on things or get things consistent. So we have to take the balance of it and do the best we can in terms of the scientific evidence that's available. Science will change as we move into the future. Okay, if you were to try to identify which characteristics a species would have if it is to be tolerant, here's what they are. High production of seeds, so you get a lot of propagules out in the landscape. High seed dispersal. Tolerant of low soil moisture, probably the most important thing. Tolerant of high air temperature. intolerant of disturbances such as wildfire. Very competitive. This will be critical in the future. Regardless of anything else, you have to be competitive with, against other species. Broad environmental tolerance, so you can probably do better if you can tolerate colder and hotter, drier and wetter. And then high genetic diversity is usually an important characteristic, and I think we'll hear more about that later today. The other question I get an awful lot is, well, how are trees going to grow in a warmer climate? Faster, slower, what's going to happen? So let's just go through this in a very general sense. Let's look at our iconic west side forest species, Doug fir, western hemlock, cedar, spruce, those sorts of species. Now, regardless of anything else, we have dry summers on this side of the mountains. And so even if we have high winter precipitation, which we've had during the last several years, if we have a dry summer, it's going to affect tree growth. And we can certainly expect drier, hotter summers in the future, so I think most of these species will have decreased growth in the future. Doesn't mean they're going to topple over and die, but they will probably be less productive in general. We look at our iconic east side species such as ponderosa pine, Doug fir, western larch. Well, those species are already moisture limited. So if we ramp up the temperature, that will pinch them even more, and we can expect that their growth will decrease as well. What about our high elevation trees? High elevation trees are energy limited, more so than water limited. So they don't have a very long growing season. If we crank up the temperature, they'll have a longer growing season, and I think there's every possibility that species such as subalpine fir, mountain hemlock, and lodgepole pine will grow faster in the future. So these are some winners potentially in the climate change game. And we have a fair amount of data we've collected over the last 20 years that seems to support this. And then if we look at our riparian areas, wetlands, groundwater dependent systems, these are extremely important in terms of biological diversity across the landscape. And anything that changes the hydrologic regime to the extent that Jessica talked about is going to have a big impact on which species will grow in these areas. It may or may not affect growth and regeneration in a particular way, but it will almost certainly change if we change the hydrologic regime. Okay. This is the part I like to get to as quickly as I can because we kind of jump away from the gloom and doom. We talk about things we can do. And there are lots of things we can do, and we're going to hear a lot about those today at this workshop. So I like to put this Gary Larson cartoon up here because I think this is how resource managers often feel, not just about climate change, but about management in general. You know, it's like, come on, you have to do something. You know, damned if you do, damned if you don't. And somebody's going to be unhappy with you. But you have to go through one of those doors. And that's what climate change adaptation may be as well. So I define adaptation as simply an effort to reduce negative consequences of climate change and transition species and ecosystems to a warmer climate. This is critical. In most cases, we will not be able to resist this. We will not be able to protect our species where they are in place for hundreds of years into the future. So the transition part is a much more realistic approach. In many cases, it's more of a fine-tuning. And I know sometimes, a few years ago, when Jessica and I were running workshops around the western U.S., a lot of the resource management colleagues were quite concerned they'd have to make this big change in their management techniques. And we would say, no, probably not. We're already doing a lot of good things out there in terms of prescribed burning, fuels reduction, thinning forests to increase vigor, and so forth. So it may just be more of a fine-tuning and reprioritization. Simply put, climate change adaptation is a new component of sustainable resource management, and it's certainly a form of risk management. Forest managers do risk management all the time. What's the risk of insects? What's the risk of fire? What's the risk of pathogens? What's the risk of climate change? Just add it to the list. So you're just making the job a little bit more complex. Okay, so how do we go about this? And I'm going to suggest a few things here. So I think, first of all, in the last 20 years or so, we've been talking about restoration of forests a lot, as if we know exactly what to do. when in fact we're experimenting. We're trying to find things that work. Now, our older concepts have focused on historic range of variation. Basically, what happened in the past, and let's use that as a target for the future. Often we use species as those targets. And it's usually done at small scales, relatively small projects that we can kind of bite off and what we can afford. I suggest we maybe think about transitioning the terminology from restoration to building resilience in ecosystems. So start incorporating this new data into planning and management. Use future range of variation, not historic range of variation. If we can get it up to the point of historic conditions, that's good, but we can't stop there. And then do this across large scales, because that's the only thing that will make difference. So regeneration is where the action is. This is where the climate change lottery happens. You know, we have a fire, we have a wind throw, we have an insect attack, and it's who regenerates and establishes himself into the future that will win the next generation. So seedlings, you know, down here at the ground level, the environment is very extreme. It's very hot during the day and it's colder at night. And so you have this kind of fluctuating temperature. So seedlings really have to be tough, and it's something to think about in terms of how we select species and genotypes for the future to be tolerant of these extreme conditions, including very hot and dry soil conditions. So a good practice is, you know, take care of your seedlings and saplings. So we have to retain that soil moisture in these small seedlings. That might mean you do things like mulch more, something we maybe didn't do very much in the future. And of course, we always have to do this. Are there deer in Thurston County? Anybody have deer? Okay. I figured as much. I heard that. All right. The other really important thing is to select species that are tolerant. You know, we have this phrase, plant the right tree in the right location for the right reason. Say that over and over again in extension classes. So on the west side, fortunately, we have some good species. Douglas fir, I think, is going to be our tried and true species in the future. Grand fir as well, it seems, in most locations, depending on soil. I've heard of some folks in southwest Washington who are now planting ponderosa pine on kind of an experimental basis. Anybody plant western white pine? Good, you're my heroes. There's lots of heroes out here. People kind of resist doing that because of the opportunity for white pine blister rust, but I also know a lot of folks are having good success with this, which is a relatively drought-tolerant species. We don't want to forget our hardwoods. When we talk about climate change and silviculture in general, it seems like we focus about 95% of our attention on conifer species because we know a lot about conifer silviculture. We don't know nearly as much about hardwood silviculture, but we're learning more. We also know that there are some very good reasons to plant hardwoods and to nurture them on the landscape. They add a lot of diversity, habitat, good values. Red alder stumpage prices have consistently been higher than that for Douglas fir for quite a while now. They don't get some of the same diseases that conifers get. Red alder is your nitrogen fixer, so you get some free fertilizer out there. And you can always underplant with conifers in hardwoods. I do an awful lot of underplanting of red cedar and grand fir in my property in Skagit County. So keep this as part of your portfolio if you can. All right. How many of you plant some native understory species as well as trees? Anybody? Okay, good. We tend to forget these as well. We have a lot of great choices for drought-tolerant species out there. Conservation districts are doing a better job all the time at stocking these for their plant sales. So I think there's some really nice ones and some things we don't think about a lot, mock orange maybe, choke cherry, but you know, put those into the mix if you can. Diversity is probably the key in many different ways to creating resilient forests in the future. You'll hear more about this. You know, having different structural characteristics out there across the landscape. And to partition your species array across that landscape by the water needs and soils in any particular landscape. So be very, very aware of things like aspect, soil drainage characteristics, and so forth when you go about planning. And this is a relatively new concept that has come up in the last decade or so. For about 40 years, we preached to everyone that thou shalt plant within thy seed zone. And when I was taught this concept, I thought that if I didn't do that, I would probably get struck by lightning, because that was how it was conveyed. And that was based on good science. If you plant trees from seeds that were collected where you're intending to plant it, they'll probably be better adapted. Now we're saying, well, maybe we need to relook at this situation, and maybe we can stretch those seed zones a little bit to include seed from areas that are a little bit warmer, lower elevation, and so forth, and you'll hear more about this later today. The other question I get an awful lot is, well, should I plant species from other locations? This is called assisted migration or managed relocation. So should I be planting incense cedar like over on the left, white fir, coast redwood? My response is, I think you can do whatever you want. If you have enough land, you want to do a little experimentation, have some fun with it. If it's not an invasive species that's going to take off, I support that. But I think we're not at this point yet in most cases. And that I think expanding the genotypes first is a good step, and then over time we can take a look at these sorts of things. But we know from past history that when we do kind of drastic changes in species locations, we often run into trouble. Now, I have a friend who's a fish biologist, and he said, well, hell, we've been doing that for 100 years with fish. And I said, yeah, look what it got us, So, I think there are some good reasons to be cautious about this, at least for now. All right. Always got to keep plants healthy, keep the trees healthy. Keeping them vigorous is the best way to resist drought. So I just like to use this analog of having too many straws in the glass. If you have 100 straws in the glass, there's a lot less water than if you have only 20 straws in the glass. So if you keep the forest managed to appropriate densities, they will tend to be more vigorous. And also, this isn't something we would do as much on the west side, but certainly on the east side, keeping the surface fuels low. All right. Here's something I'm sure that Derek's going to follow up on later this afternoon. This concept of variable density thinning. So doing some traditional activities a little bit differently than we used to. In this case, the spacing of trees, the density of trees across the landscape. There's not really a recipe for this. Again, landowners can experiment with this a bit and see how it works in the future. The one thing that we can always do that will create more resilient systems is to reduce the stressors, reduce the non-climatic stressors. That's something we should be doing anyway. So removing non-native species, for example. Has anyone ever cut knotweed like that on the left? I always use this photo just because I love the photo. And I can just imagine what those guys were feeling out there that day. Purple loosestrife. So, do those things that you can do, that you can afford to do, and that make a difference. All right. So here's just a quick summary of what can be done. As you go about planning and doing forest management, think about 30 years from now. Warmer temperatures, higher extremes will probably be what we're dealing with after the middle of the century. So think about those species and conditions and portfolios of your landscape that will work. Diversification, diversification, diversification. It's probably our best option for the future. When you do have disturbances, whether it's a fire, insects, pathogens, whatever, the tendency is to put your head in your hands and cry. But I think when those do happen, we can make lemons into lemonade and use it as an opportunity to do something different. Plant some different genotypes, use some different spatial structures out there. And to truly do risk assessment and risk management, we haven't, so much scientific information now. You don't have to grope around out there. You can make a pretty good estimate on what might happen in the next 30, 40, 50 years and then plan accordingly. And then to monitor the effectiveness of what you do out there. I think there's a tendency to, not private land management, but certainly in federal land management, which I've been associated with most of my career, if we do a riparian monitoring restoration project, something like that, we'll implement those actions and we walk away from it. And we assume it's going to work. But we have to track what works and what doesn't work. not just for our landscapes, but then we can share that information more broadly across the community, so we have a better chance of success in the future.